Bismillahirrahmanirrahim. In this session, we will discuss second order derivatives uh, from for additional mathematics course for IGCSE and O level. And in this section or chapter 12, section 12.8, we will take discuss second order derivatives, and this is dy by dx is the first order derivative, and this takes the derivative again, then this becomes a second derivative and a higher order derivatives. So let's move to exercise 12.8. Find the second order derivatives of y with respect to x for each of the following section. So secondly, for problem number 2, we will do the same. So we'll do 1 or 2 from problem 1, and then 1 or 2 from this, and then third and fourth problem. So let's move to problem number 2. That's part E, 1E. We have y is equal to under root 2x plus 1, and that is 2x plus 1 power half. We take the first derivative. This is half here, and then half minus 1, and then we take the derivative of this part is here. So this is 2 by 2 cancel out, and this 2x plus 1 is minus half. So this is dy by dx, and then now we take the derivatives again. This minus half is here, and then minus half minus 1, and then take the derivative here. This is again here. So this 2 will cancel out with this minus sign is here, minus is here. So this is minus, this is power comes down to a positive form. So this minus 1 over 2x plus 1. So this is the second derivative. This is part E. Let's move to question number 2, and where we have this y is equal to x minus 1 power 3. This is u, this is v. So u dv by dx, and then v dv by dx. So this is x minus 4 square is common, so this is 3x, and here x minus 4, so this is 4x minus 1. So 4 is taken common here, x minus 1, and this x minus 1. So this is dy by dx, and we take the derivatives again. So this is u and v again, perform the same, and the result we have obtained this, and then we'll simplify it, and eventually with the simplification we have obtained like this. This will add up, and then this one minus 6, 3 will be taken common here, x minus 2 here, so this x minus 2, this 3 multiplied, this is 12. So this is x minus 2, x plus minus 2. So this is the derivative, second order derivative. We take out the first derivative and then simplify it, and then take out the second derivative and finally simplify it to make this equation. This is part 2. Now let's move on to last one. Let's solve part D. So this is x plus 2 x square minus 1. This is u, this is v. So v u dash, u v dash. So this is v square. Simplify. We have obtained this. Again, take the derivative, and this is u, this is v. The second order derivative will obtain this. This is v square. So this is v, so this is v square. So rather than simplifications, we eventually obtain this. So this is part E. Finally, we will cover the question number 3. So find the fx f1, so we'll place 1 here and we'll get this value. Same for f1 dash, so we'll take the first derivative and then put the value 1, gets the value. And similarly for the last one, we take the double derivative of this and then put the value. This is it. So 154. Let's move to problem number 5 and then 6, 4. Okay, let's move to problem number 3. So this is problem number 3. We have this fx equal to this, find f1, so we'll place the value 1 here and then substitute minus 3. Now find f dash x, so this is differentiated with respect to s, we get this one and place the value 1 here and we get the value this. For second order derivative, let's take this second order derivative for this one. It is 6x minus 14. Place the value 1 and let's see. So this was very simple. Now 1. Let's move to question number 6. A curve has equation this, find the range of values of x for which both dy by dx and d second derivative of dy by dx square are both positive. So we have to find the range where the values of x for which this first derivative and second derivative gives both positive limits. So we have to find the range of values of x. So this is problem number 6. So we will move to problem number 6. So this is problem number 6. Now we take the derivative of this, and here we have this 2x cube plus 3x square minus 36x plus 5. And if we take the first derivative, this becomes 6x square, this becomes 6x, and this is 36. So we take out the 6 here, have a common, and dy by dx. So this is our dy by dx. Now take the second derivative, this one, this is 12x and this is 6. So we take out the 6 and check that this is greater than 0. So we check that this is greater than 0. So for x is greater than 2, we see that when x is greater than 2, both will be positive. So this is x is greater. So in this case, we see that when we put x is greater than 0, this will be positive, and for x greater than 0, this will also be positive, because this is positive for minus half. So for x is greater than 2, this will be positive and this will also be positive. For less than this will be negative. Or equals to 2, it will be 0. So this is the condition. So this was the required condition. Now let's move to 6. A challenging problem. Given that y is equal to 8 under root x, show that 4x squared d second derivative of y plus 4x dy by dx is equal to y. Okay, so let's move to 1. This is challenging one. So y is equal to 8 under root x. Show that 4x squared d double derivative of yx dx squared second order plus 4x dy by dx is equal to y. So take the left hand side first. 4x squared double derivative of y with respect to x plus 4x dy by dx. So in place of this dy by dx is y is dy by dx is this, and d, the second derivative of this is, take the derivative once more, so we'll have this there. So we'll place this according to this left hand side. So we'll place the second derivative here and the first derivative here on the left hand side, and this is operated like this. This is the second order derivative, the first order derivative, and this is the coefficients. This is also there on the left hand side. This is minus 8. So we solve it, simplify it, and we get this. So this is 8 under root x, which is y, which is the right hand side. So we take the left hand side and then prove that that's equals to the right hand side. This was the 12.8. In the next session, we'll discuss 12.9, where the stationary point is very, very important with respect to the final examination.